Welcome to the Maris SRF Partial Reflection tutorial. In this video, I will showcase an exciting new feature of the Maris SRF numerical tool. It allows you to modify, in an interactive way, the bathymetry file to facilitate the specification of eddy viscosity coefficients and emulate partial reflection in the Maris HMS wave agitation model. Let's jump right into it. For this tutorial, I have already navigated in the Maris SRF page and selected an example port agitation project. I now select the option Insert Bathymetry Files, and from the pop-up window, I select the file depth, dn.csv. Once I am finished, I press the Edit Bathymetry File option to open the interactive tool. This tool will allow me to modify just the land values of the bathymetry file that are bounded by wet points. By clicking anywhere in the file, I can view the bathymetry values on the table below. I will now zoom a bit to the windward breakwater of the port. I can see that all the land values have a value of 10. The way the tool works, I first have to specify the value based on which I will select the land points, and the new value, which will replace the initial ones. For my case, I will replace all values of 10 with a value of 20. I am now ready to select the points I want, pressing the Drawline button. I navigate close to the land boundary of the windward breakwater and start clicking. When I want to finalize my selection, I double-click. I notice that the points selected are illustrated with a black color on the picture and also shown with a dark gray font on the table below. When I am ready to confirm the changes, I press Save. The modified values are now shown with a red color to help if I want to make additional changes. For example, I can modify any values I want on the table below, and press Save once again. Also, don't worry if you click inside the land, it can still locate the appropriate land points. Pretty handy, right? Now that I am satisfied with the changes I made, I can close the interactive tool. I will now enable the Eddy Friction Map option in the Maris SRF interface and focus on the Reflection Eddy Calculator. This functionality enables you to estimate the relationship between the eddy viscosity and reflection coefficients, depending on the sea state wave characteristics and geometry at the toe of the structure. For my case, the breakwater's toe is located at a depth of 7 meters. The estimated values for the wave characteristics concern an irregular sea state, a significant wave height of 2 meters, and peak wave period of 6 seconds. The field width of layer specifies for how many meters directly offshore the breakwater the eddy viscosity values will need to be applied. Now I press the Calculate button. After a little bit, SRF produces a graph depicting the relationship between eddy viscosity and reflection coefficients. Since I have identified a reflection coefficient of 0.5, the corresponding eddy viscosity value to be applied to achieve this reflection is 4.5. Now, directly to the left, I indicate that for a land code value of 20, SRF should apply an eddy viscosity coefficient of 4.5. The number of layers is the quotient between the width of layer of 10 meters I specified before and the bathymetry spatial step size, which is 2.5 meters in my case. So, I leave the default value of 4 in this field. I can also name and save my file, and submit the SRF simulation. This concludes the tutorial for the Maris SRF Partial Reflection interactive tool. We hope this tool can significantly ease the burden from your pre-processing and further improve the simulation times.